All right, let's get right into it. We've all heard about black holes, right? The giant cosmic monsters lurking out there in the dark. But what if? What if they have an opposite, a cosmic twin that does the exact reverse?
I'm talking about those spots in the universe that just consume everything around them. Light, time, even information itself. They're what we call black holes, the ultimate point of no return.
Now try to flip that idea completely on its head. Can you even imagine an object that doesn't swallow anything, but instead violently shoots matter and energy out into space? Well, that is exactly what scientists call a white hole. So what exactly is this cosmic enigma? Well, to really get a handle on a white hole, we first have to talk about its more famous and, much darker symbol.
See, the idea for white holes didn't just come out of nowhere. It actually comes directly from the same mathematics that predicted black holes in the first place. They're basically two sides of the same coin in Einstein's equations.
So here's the key thing about a black hole. It's a one-way street. Once you cross that boundary, the event horizon, there's no coming back. It is, quite literally, a point of no exit.
A white hole is the perfect mathematical opposite. Think about it like this. Imagine you took a video of matter falling into a black hole, and then you just played that video in reverse. That explosive fountain of stuff flying out? That's essentially a white hole. So if a black hole is a point of no exit, a white hole is a point of no entry. You just can't get in. And when you put them side by side like this, it's honestly kind of wild how perfectly opposite they are. Black holes swallow. White holes expel. In black holes, matter only ever goes in. In white holes, matter only ever comes out. But here's the biggest difference. We have actual, hard evidence that black holes are real. White holes, for now, they're purely theoretical. So that leads to a pretty fascinating question. If they do exist, where would they come from? The most popular theory sounds like something straight out of science fiction. The idea is that a black hole could act as an entrance, a gateway that pulls matter in. This matter would then, theoretically, travel through a tunnel in space-time, a wormhole, and erupt out the other side from a white hole.
This illustration really captures the idea perfectly. You see matter falling into that deep gravitational well of the black hole, passing through this cosmic bridge, and then being shot out from the white hole. And who knows where that other side even is? It could be in a totally different part of our universe, or maybe even in another universe entirely.
Okay. If this is even a remote possibility, then where are they? Why haven't our telescopes ever seen a giant fountain of matter erupting somewhere in space? Well, this is where the theory runs into some pretty major roadblocks.
First, for a white hole to even form, you'd need conditions of pressure and energy that are just, well, they're basically impossible in the universe as we know it. Second, even if one did pop into existence, it would probably be incredibly unstable. And here's the real deal breaker, because nothing can enter a white hole, any little speck of dust that got near it would essentially get stuck at the edge, causing the energy to build up until the white hole instantly collapses into a black hole.
But there is one other idea, and this one is even grander. It's a theory that connects the idea of a white hole not to just one object, but to the very beginning of everything. What if our own origin story, the Big Bang itself, was actually the eruption of a single, colossal white hole?
Now, this is definitely a wild idea, but it's not just a fantasy. It's a serious line of research. It suggests our entire universe might just be the explosive other side of a black hole that exists in some other parent universe. It's a truly mind-bending thought.
So after all that, we're left with the ultimate question. Are white holes a real, hidden feature of our cosmos, or are they just a ghost in the equations?
It's completely possible that white holes are nothing more than a mathematical quirk, a solution that looks beautiful on paper but just doesn't happen in physical reality. And hey, it wouldn't be the first time that's happened in physics. But on the other hand, they could be real, a profound piece of our cosmos that we just haven't figured out how to discover yet. Maybe they're incredibly rare, or maybe they exist in a way our technology just can't see. The possibility is still there. But whether they're real or not, the story of white holes is a powerful reminder. It shows us that the universe still holds secrets far greater than we can possibly imagine. And it really makes you wonder, what other incredible ideas are just waiting for us, hidden somewhere in the math of the cosmos?